All right, so 4.2 rotations, radians, and degrees. Before we do anything farther, let's go ahead and talk about how you would do some converting from degrees to radians. And then on this side, I'm going to talk about how to convert from radians to degrees. All you got to do, guys, if it's in degrees, all you need to do is just multiply by pi over 180. And we'll do an example here in a little bit. For radians to degrees, you multiply by the reciprocal. So 180 is going to be on top, pi is going to be on the bottom. That's it. Okay, so guys, degrees on a coordinate grid can be positive and negative. So look, if I go to draw an angle and I move up, that's positive. So if I start going up to draw an angle, it's going to be positive. That's also known as counterclockwise. And that is certainly positive. I'll just write positive over here. We're also going to draw negative arrows. If I draw a negative arrow, what I would do is I would just go down. This is called clockwise. And remember, this is negatives. All right, so let's actually talk about making angles on a coordinate grid. So in this little, like in the middle of this space, I'm still going to be above the second hole of my paper, so the top half of my paper. I'm going to draw an X and Y axis, kind of floating over here to the left, to the right of the center, because I'm going to write some concepts right here. So let's go ahead and sketch an X and Y axis. And there's something called standard position of an angle, which is really important. All of us have to be in standard position. So here's how standard position works. You always start on the positive side of the x-axis. I'm just going to bold that out a little bit. And your vertex is always anchored on the origin. And then we're just going to rotate up, down. When we rotate and create the angle, the side that makes the angle stop is called a terminal side, which makes sense. Terminal means stop. So I'm just going to write, here's where theta is. So that is called standard position. I'm going to write standard position over here. Usually I'm not a big vocab person, but I am going to ask you to know what standard position of an angle is. And just remember, it's three things. It always starts on the positive side of the x-axis. The vertex is always anchored on the origin. And when I mention the word terminal side, just remember that's where the angle stops. Okay, so since it's anchored at the origin, we're just going to be rotating. Sometimes I'm going to rotate up. It's going to be counterclockwise. Sometimes I'm going to rotate down. It's going to be clockwise. So let's talk about rotations, because when you do a rotation, you're going to have to find the degrees and the radians. So let's say we have a rotation. I'm going to show you how to convert that to degrees. And then we're going to convert it to radians to get that practice in there. All right, let me kind of adjust the way this looks. I'm going to zoom in to just this portion. There we go. Autofocus. All right, so here we go. Let's pretend that we were doing 1/6 of a rotation. To do that, and to get it in 2 degrees, of course, we are going to multiply by how many degrees are in a circle? How many degrees are in a circle? Yeah, 360, yes. And we're going to make a positive angle, so keep that 1/6 positive. And guys, what's 360 divided by 6? Yeah, so the degrees is 60. It's positive. And then remember, look at your top of your paper. To convert that to radians, we're going to multiply this by pi over 180. So it's going to be 60 pi over 180. 6 over 18. What does 6 over 18 simplify to? Yeah. So the radians, which you should already know because 60 degrees is on the unit circle, it's pi over 3. Let me try to think of one. It's not going to be too ugly that's negative. Let's say we had a negative 7/8. We're going to do a rotation of negative 7/8. Let's multiply this by 360. I hope this is not ugly. Let's turn on this calculator. Y'all got your calculator, right? Negative 7 times 360. Then we're going to divide that by 8. It turned out to be a nice number. I got lucky. That is going to be a negative 315 degrees. Let's multiply that by pi over 180 and we'll get our radians. All right, so look at my calculator. I'm just going to hit divide by 180. I know that pi is going to be on the top. And I get negative 1.75. Most of you guys should know how to convert that to a fraction. I mean, we all know 0.75 is 3/4, right? Let's pretend it was a weird decimal. These will convert fractions to you, for you, not to you. The conversion from a fraction to a decimal is right above the PRB key. So hit yellow, hit your yellow key, then hit F to D, hit enter, and then there it is. It gives it to you as a mixed number, so I know this is negative 1 3/4. We always write our numbers as improper fractions. So let's go ahead and write this as negative 7/4 pi. All right, and that's converting. Any questions on that? We're going to move on to our next concept that's going to be on the front of the paper. It's called coterminal angles. And coterminal angles are exactly what this sounds like. Coterminal angles just share the same side of where the angle stops. Ooh, I need to scoot my paper down. Okay, so I'm kind of at the bottom quarter of my paper. Let me kind of organize my space here. What we're going to do is, if you could, just sketch an X and Y axis over here, kind of on the left side of your paper. And we're going to draw quite a few things on this. So the first thing we're going to draw is an angle. Let's draw an angle in the first quadrant. And let's say this angle is 50 degrees. All right, so this angle of 50 degrees can share an angle, a coterminal angle, with another angle. Let's say I'm going to draw a positive angle. Let me draw this first, and then you guys can see what's going on. So I'm going to draw a positive angle. I'm going to go up. I'm going to kind of make it dotted so it doesn't get crazy. Now remember, I can't stop there because it would be the same exact angle. So if I keep going, now I can stop because the angle measures are different. So this coterminal angle is going to be 50 degrees plus, look, I went all the way around 360. So on my little handy, pretty pink calculator, clear, if I do 50 plus 360, I get 410. So 410 and 50 are coterminal angles. Look, I could add another 360 and get 770. That's another coterminal. I could just keep adding 360. All of these are coterminal angles. I could do this forever. So there's an infinite number of coterminal angles for any angle. So, what was it? 410, right? So your formula for this is going to be whatever the degrees are for theta, you're always going to add 360 times the number of wraparounds. I'm just going to say the letter N for the word number. The number of wraparounds that you do to go back and touch your terminal angle. So this is always going to give you your coterminal. I'm going to abbreviate your coterminal degrees. Now look, that same formula works for going down also. Let's draw a negative angle. Now when I draw a negative angle, I don't have to wrap around twice because I can just stop on that terminal angle because it's going to be different. So if it's negative, another coterminal angle for 50 degrees is going to be 50 minus 360. So my pretty pink calculator. Now I'm going to do 50 minus 360. So negative 310 is a coterminal angle of 50 degrees. And again, I can just keep hitting minus 360, minus 360. Coterminal angle, coterminal angle, coterminal angle, forever. So this formula works. Just remember that N can be positive or negative. It's going to be positive if you're going in the positive direction, of course. It's going to be negative if you go down. So that's how we find coterminal angles. Ooh, I am off the screen there. All right, let me zoom out. Let's kind of take a look at everything we did. Let's recap for a moment. All right, so first of all, absolutely, you are so going to have test and quiz questions on this. No doubt about it. And remember, I'm not giving you any formulas. I am most certainly going to ask you the opposite also. Remember, no formula is ever given. Ooh, I like that better anyway. What else? Again, I'm not really a vocab person, but you are certainly going to have to know what standard position is. And yes, I am going to ask you, hey, here's a blah, blah angle. What's a positive coterminal angle? What's a negative coterminal angle? And I am not giving you this, so make sure you have that memorized also. All right, any questions? Let's flip it over to the back. And let's rotate our paper to landscape mode. So on the back, flip it on its side because it's just going to fit nicer. We're almost done. We're like over halfway done. This is just going to be a cleaner picture for you. So on a coordinate grid and trig, there's something called a reference angle that's been hiding this whole time. And let me show you what this is about. Let's write reference angle at the top. Reference angles. That's what I'm going to write. There's 3 characteristics about reference angles. They're always positive, no matter what. It's always less than or equal to 90 degrees. and it always touches the x-axis. So the reason why I asked you to do landscape is because we're going to draw 4 coordinate grids across the length, because we're going to examine angles in each 4 quadrants. So let's go ahead and draw 4 coordinate grids. I'm going to try to space my grids apart. So what I'm going to do is I'm just going to draw 4 horizontal lines. And then I'm going to go back and draw my y-axis. Y'all, half the time the word's coming out of my mouth. And when we draw the angle, let's just pretend it's 60 degrees. All right, so this is in quadrant 1. Now remember, a reference angle is always positive. Less than or equal to 90 degrees always touches the x-axis. So the reference angle for this angle is actually nested right on top of it. Because remember, it has to touch the x-axis, and it has to be less than 90 degrees, and it always shares a side. It shares a side with the angle. So in quadrant 1, your reference angle, I'm going to write RA. You're going to see that a lot. That stands for reference angle. Your reference angle equals whatever theta is, whatever the angle is. Excuse me. So in this instance, my reference angle equals 60 degrees. Let's write that in radians. Y'all should know that. That was on your unit circle. What's 60 degrees in radians? 60 degrees? Pi over 3. Good. Let's draw an angle in quadrant 2. Let's just double it. Let's draw a 120 degree angle. So just kind of estimate where you think it is. Remember, these are not drawn to scale. They're just sketches. All right. So remember, your reference angle always touches the x-axis, and it always touches the angle. But this time it's on the outside of it because it has to be less than or equal to 90 degrees. So the reference angle is right here. So my reference angle, it's not going to equal theta. It's not going to equal 120. What does it equal? Yes. How'd you get 60? Mm-hmm. Perfect. So your reference angle, whenever it's in quadrant 2, it's going to be 180 minus theta. So 180 minus 120, 60 degrees, pi over 3. All right, let's draw an angle in quadrant 4 or 3. So let's draw something different, not an increment of 60s. Let's do 225. So we drew an angle all the way over there, and it is 225 degrees. Oh, look, y'all, that is not supposed to be a 0. I forgot to draw my line through theta. Make sure you have theta symbols right here. I'm sorry. All right. Now remember, it touches the x-axis, has to be less than 90 degrees. I can't draw it on this side because it would be over 90 degrees. So it's right here. So this time, how are we going to figure that out? What is that?
45.
It is 45. How'd you get that?
180 is straight, and 225 is an angle, so subtract 225 by 80.
So this time it's theta minus 180. Good. Great job. So our reference angle here is 45 degrees. And what is that in radians? Pi over 4. All right, let's draw one in quadrant 4. Let's just make up something weird so that it'll be different. Let's draw a 301 degree angle. All the way around. It's 301 degrees. Now remember, excuse me, has to touch the x-axis, has to be less than or equal to 90 degrees. So it has to touch that side of the x-axis. That way it's going to be less than 90 degrees. How much is that angle? Say again?
59.
It is. And how'd you get that?
The 360
360 minus theta. Oh, this will be fun. I don't have this. I don't know what this is in radians. Let's figure it out. Turn on your calculator. Where's my calculator? All right, so that's in degrees. How do I convert it to radians? What do I multiply by? Pi over 180. Very good. So it's just going to be 59 divided by 180. Now remember, it's going to give you a decimal. We hate decimals in higher level math classes. Do y'all remember how to convert that? Remember, you hit the second PRB. Oh, it doesn't simplify. So it's just going to be 59 pi over 180. So there's your radians. And that is reference angles. That's how you find your reference angles. Please remember they're always positive, less than or equal to 90 degrees, always touches the x-axis. However, I drew all of my angles positive. What if I went negative? So look, if I have a negative angle, let's draw one more x-axis if you guys can fit this. Let's draw one more x and y-axis. And let's pretend I drew a negative angle. Let's not pretend. Let's just draw a negative angle. I'm going down. Let's go ahead and keep it in this first little section right here. So I went down, and let's say that's I went down negative 60 degrees. Now, when you go down, you are going to treat this as quadrant 1. You're going to match your angle to like what we did in quadrant 1. This would be quadrant 2, this would be quadrant 3, and this would be quadrant 4. So if I go down negative 60 degrees, what is my reference angle? What would it look like if it was up here? Remember, it has to touch the x-axis, has to be less than 90, positive 60 degrees. Yep, positive 60 degrees. So guys, you're just going to treat it opposite. You're just going to treat it as opposite degrees. Okay, good. So